Hello, in this lecture we'll find out the ratio between two radii. In the drawing we have a big circle. Inside this big circle we have two smaller circles. Note that the radius of the smallest semicircle is A, the radius of this circle is B, and we have to find out the ratio B over A. In addition, we know that AN equals to NC. So inside the biggest circle we have a right triangle ABC that is partially located inside the biggest circle. This angle ABC equals to 90 degrees. The length of AB is 5. The length of BC is 12. Again, our mission is to find out the ratio of P over A. Okay, so first of all, we implement the Pythagoras theorem on the right triangle ABC. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The right triangle ABC, the hypotenuse is AC, therefore the square of the hypotenuse is AC squared. Is equal to AB squared plus BC squared. Okay, again, according to the Pythagoras theorem, in the right triangle ABC, AC squared equals to AB squared plus BC squared. So AC squared equals to AB squared. AB is 5, therefore AB squared is 5 squared, that is 25, plus BC squared. BC is 12, therefore BC squared is 12 squared, that is 144. In total, AC squared equals to 25 plus 144 is 169. You take out all of this equation and you get that AC equals to the square root of 169 is 13. So the hypotenuse AC of the right triangle ABC, AC equals to 13 units in its length. At point N, the hypotenuse AC is bisected into two halves. The first half is AN and the second half is NC. So I can write down that AC over 2, that is 13 over 2, is equals to this first half, that is AN, is also of course equals to the second half, that is NC. So AN equals to NC equals to 13 over 2. So we can write here that NC equals to the second half is the hypotenuse AC is NC, that is equal to 13 over 2 units in its length. The next step, I present to you a new rule number 8, and we implement rule number 8 in our drawing. According to rule number 8, the radius of a circle that is blocked by a right triangle is equal to R is A plus B minus C over 2. So we have here the right triangle ABC, this angle ABC equals to 90 degrees, the length of AB is A, the length of side BC is B, and the length of the hypotenuse AC is C. And according to rule number 8, you can find out the radius of any circle that is blocked by a right triangle only by knowing the side lengths of the triangle, of the right triangle itself. That is to say, the radius R of this circle that is blocked by the right triangle ABC will be equal to A plus B minus C over 2. Okay? You can implement rule number 8 in our drawing. Our drawing, we have the right triangle ABC that blocks this circle. The radius of this circle is A. According to rule number 8, the radius A will be equal to AB plus BC minus the hypotenuse AC over 2. Repeat again. According to rule number 8, the radius A will be equal to AB plus BC minus AC over 2. AB is 5, according to what is given as the question. BC is 12. Minus the hypotenuse, we just right now found out that the hypotenuse AC is 13 over 2. So in conclusion, found out that AB is 5, BC is 12, and AC is 13. 5 plus 12 is 17. 17 minus 13 is 4. And 4 over 2 is 2. So in conclusion, found out that the radius of the smaller circle A equals to 2 units. Here, A equals to 2 units. And I feel that A equals to 2 units. In the next step, we define the center of this circle as P. We define the center of this circle as Q, and we define the center of the biggest circle, this point, as O. We define the point of tendency of tangent AB with this circle as T. We join points P and T together by a straight line. Point P is the center of this circle, point T is the point on the circle itself, therefore PT is the radius of the circle, that is equal to A, and then equals to 2. The radius PT is drawn to point T, that is the point of tendency of tangent AB with the circle. And whenever we have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius TP. If AB is perpendicular to TP, it means that this angle equals to 90 degrees, and this angle will be also equal to 90 degrees. Likewise, we define the point of tendency of tangent BC with this circle as N. We join points P and N together by a straight line. Pn is the radius of this circle that is equal to 2. The radius Pn is drawn to point N, that is the point of tendency. That is the point of tendency of tangent BC with this circle. And therefore, tangent BC will be perpendicular to the radius NP. That is to say, this angle equals to 90 degrees, and this angle is also equal to 90 degrees. So in quadrangle PTBN, this angle ABC of course equals to 90 degrees. So in quadrangle PNPT we have 1, 2, 3 right angles. The sum of 3 right angles is 90 times 3 is 270 degrees, plus the fourth angle, the missing angle. In total the must be equal to 360 degrees. Therefore the missing angle here must be equal to 90 degrees, according to the rule that the sum of the angles in any quadrangle is equal to 360 degrees. So in quadrangle TB and P we have 4 right angles. Any quadrangle that has 4 right angles must be at least a rectangle if not a square. So we relate to quadrangle TP and B. It's a rectangle. We know that the opposite sides of a rectangle are equal to each other. That is to say Pn equals to Tb. But Pn is 2, therefore Tb must be also equal to 2. Likewise, in rectangle TPBN, Tp must be equal to Bn, but Tp is 2, therefore Bn must be also equal to 2. So we found out that quadrangle TPBN is not a rectangle but a square because all of its sides are equal to each other. It is given us the equation that BA equals to 5 units in its length. We just right now found out that TB is 2. So AB minus TB is 80. Again, AB minus TB is 80. AB is 5, TB is 2. 5 minus 2 is 3, so 80 is 3. And we also know that rule number 2, that the lengths of two tangents from a common external point to a circle are equal. We have the common external point point A. From the common external point A, we have two tangents to the circle, tangent AT and tangent AM. And according to rule number 2, they are equal to each other. That is to say, AT equals to AM, but AT is 3, therefore AM must be also equal to 3. We have already found out that AN is one of the hypotenuse AC, and the hypotenuse AC equals to 13, therefore AN equals to 13 over 2, AM equals to 3. AN minus AM equals to MN. Again, AN minus AM equals to MN. I'll write it down. AN minus AM is equal to MN. AN is 13 over 2. AM is 3. Here we multiply 3 by 2, we multiply minus 3 by 2, and then we divide it by 2 in order to have a common factor with 13 over 2. So here we have 13 over 2, minus 3 times 2 is minus 6. 13 minus 6 is 7, so in total this expression equals to 7 over 2. That is to say, Mn equals to 7 over 2. Mn equals to 7 over 2. So we can write here in the drawing that this line segment Mn, it is equals to 7 over 2 units. So in the next step I will present to you rule number 7 and we'll implement rule number 7 in our drawing. According to rule number 7, if a line segment that is drawn from the center of a circle bisects a chord, then the line segment is perpendicular to the chord. So here we have the center of the circle is here at point O. line segment OM bisect chord AB. That is to say, AM equals to MB. And whenever you draw a line segment from the center of a circle, in this case it is point O, that bisect the chord, like here, that AM equals to MB, then the line segment OM will be also perpendicular to the chord. That is to say, this angle equals to 90 degrees and this angle equals to 90 degrees according to this rule, rule number 7. You can actually implement rule number 7 in our drawing. Point O is the center of the bigger circle. We join points O and N together by a straight line. Line segment ON bisect chord AC. Why? Because AN equals to NC. Therefore, whenever we have from the center of a circle, that is to say from point O, a line segment that bisects a chord, it will be also perpendicular to the chord. So ON is perpendicular to AC. It means that this angle equals to 90 degrees and this angle will be also equal to 90 degrees according to rule number 7. So you can write it that ON is perpendicular to AC. ON is perpendicular to AC. In addition, we know that point Q is the center of this circle, point N is the point of the circle itself, therefore QN is the radius of this circle. QN is the center, is the radius of this circle, is equal to B. The radius QN is drawn to point N, that is the point of tendency of tangent AC with this circle, and whenever you have a radius that is drawn to the point of tendency, then tangent AC will be perpendicular to the radius NO. If AC is perpendicular to NO, it means that this angle equals to 90 degrees and this angle also equals to 90 degrees. So we found out that QN is also perpendicular to AC. You can write here that QN is also perpendicular to AC, and from those two equations, ON is perpendicular to AC and QN is perpendicular to AC. We derive that point O must be located on the radius QN. In point O, that is the center of the bigger circle, must be located on the radius QN. Okay. Here, this is point O, that is the center of the bigger circle. It is located on the radius QN. Why? Because if QN is perpendicular to AC at point N, ON will be also perpendicular to AC only, and only if it is located on QN. Otherwise, if for example point O is not located on QN, it is located here, you get that ON will not be perpendicular to AC here. If we draw the straight line ON, it will not be perpendicular to AC. Point O must be located on QN in order that ON will be perpendicular to AC. So point O must be located on QN, and therefore all the 3 points Q, O, and N are located on the straight line, that is to say QON is one straight line. Okay? QON is one straight line. Line segment QON is one straight line. In this point, this circle touches the biggest circle. This is the point of tendency between the two circles. We define the point of tendency as U. In the next step, we'll draw tangent VW. This is tangent VW. That is tangent to both circles, to the biggest circle and to this circle at point Q. Again, point Q is the center of the circle, point U is the point of the circle itself, therefore Q is the radius of this circle. The radius QU is drawn to point U, that is the point of tendency of tangent VW with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent VW will be perpendicular to the radius UQ. If VW is perpendicular to UQ, it means that this angle equals to 90 degrees and this angle also equals to 90 degrees. So you can write down that the radius QU is perpendicular to tangent VW. The radius QU is perpendicular to tangent VW. In addition, point O is the center of the biggest circle. Point U is the point on the biggest circle itself. This is exactly the definition of a radius. So OU is the radius of the biggest circle that we will define as x. The radius of the biggest circle is x, according to our definition. So the radius OU is drawn to point U, that is the point of tendency of tangent VW with the biggest circle. And whenever you have a radius that is drawn to the point of tendency, then tangent VW will be perpendicular to the radius UO. If VW is perpendicular to UO, it means that this angle equals to 90 degrees and this angle equals to 90 degrees. So we can write down that OU is also perpendicular to VW. The radius OU is perpendicular to tangent VW. And from those two equations, QU is perpendicular to VW and OU is perpendicular to VW, we will derive that line segment OQU is one straight line. One straight line. Here, this line segment OQU is one straight line. That is to say, all the 3 points O, Q, and U are located on the same straight line. Otherwise, if for example point U is not located on the same straight line as QU, and we know that QU is perpendicular to VW at point U. So if for example point O is located here, then the straight line OU will never make angle of 90 degrees with VW. Here this will be the straight line OU that will never make an angle of 90 degrees with the VW. Here it will be smaller than 90 degrees. Okay, so all the 3 points O, Q, and U must be located on the same straight line in order that QU will be perpendicular to VW and OU will be also perpendicular to VW. That is to say, OQU is one straight line. So OQU is one straight line and QON, we already found out that QON is one straight line. Okay, and from those two expressions that OQU is one straight line and QON is one straight line, we will derive that NQU is one straight line. NQU is one straight line. So actually, if line segment NQU is one straight line, it means that NU is also a straight line. NU is a straight line. So NU is a straight line. The straight line NU touches the circle at points N and U. Therefore, NU is a chord that passes for point Q, and point Q is the center of the circle. Point Q is the center of the circle. So any chord that passes for the center of the circle must be the diameter of the circle. Therefore, NU is the diameter of the circle. I write it down. NU or UN, doesn't matter. UN is the diameter of the circle. NU is the diameter of the circle. And we also know that the diameter of any circle is twice as long as the radius, and the radius of this circle is b. Therefore, the diameter NU must be equal to, or UN, the diameter UN must be equal to 2b. UN equals to 2b. I'll repeat again here. UN equals to 2b units in its length. Okay. In the next step, we join points O and P together by a straight line. Point O is the center of the bigger circle. Point P is the center of the smaller circle. So we join the centers of the two circles together. That is to say, line segment OP connects the two centers with a straight line. OP is the straight line that connects the centers of the two circles together. Then I present to you rule number 9. According to rule number 9, if two circles touch each other internally, then the straight line that connects their centers together must pass for their touching point. The center of the big circle is here at point O. The center of this small circle is here at point N. The straight line that connects their centers together is the straight line OM. According to this rule number 9, the straight line OM must pass for point P, that is their touching point. The two circles touch each other at point P. So OMP is one straight line. If OM must pass for point P, it means that OMP is one straight line. So here we can implement rule number 9 in our drawing. Why? Because in our drawing, the smallest circle here touches the biggest circle at this point. Define the touching point as point S. Here. The smallest circle touches the biggest circle at point S internally at point S. Okay. So according to rule number 9, the straight line OP that connects the centers of the two circles together must pass for point S. That is to say, OPS is one straight line, okay? OPS is one straight line. You can write down that OPS is one straight line. So if OPS is one straight line, it means that SO minus SP is PO. Again, SO minus SP is PO. Write it down. SO minus SP equals to PO. You should remember that if SPO is one straight line, it means that SO is also a straight line. If SPO is one straight line, then SO is also a straight line. So what is the definition of the straight line SO? Point O starts from point O starts from the center of the biggest circle. The point O is the center, is located at the center of the biggest circle. Point O is the center of the biggest circle, and point S is the point of the biggest circle itself. This is exactly the definition of a radius. So SO is the radius of the biggest circle that is equal to x. So you can substitute SO by x. And we already found out that SP is the radius of this circle. Why? Because point P is the center of the smallest circle and point S is the point of the smallest circle itself. Therefore, PS or SP is the radius of the smallest circle that is equal to 2 units. SP is 2, so we substitute SP by 2. So in conclusion, we found out that PO equals to x minus 2 units. Okay, PO is 97 PO, it is equal to x minus 2 units in its length. In the next step, we'll extend the perpendicular ON by a straight line. So we extended the ON as a perpendicular, it is absolutely a straight line. When we extended the straight line ON by a straight line, the result is OT. And we extend the straight line by straight line, the result must be a straight line, so OT is a straight line. OT is the straight line. If we focus on this side of the straight line, OT at point N, here the sum of the angles must be equal to 180 degrees. According to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at this side of OT point N, we have this angle is equal to 90 degrees plus the missing angle. In total, they must be equal to 180 degrees. Therefore, the missing angle here must be equal to 90 degrees. In order to complete the sum of the angles on this side of OT at point N to 180 degrees, the missing angle here must be equal to 90 degrees. We know that CA is tangent to the smallest circle at point M. Point M is the point of tendency. We join points P and M together by a straight line. Point P is the center of this circle, point M is the point of the circle itself. Therefore, PM is the radius of this circle is equal to A and A equals to 2. The radius PM is 1 to point M, that is the point of tendency of tangent AC with this circle. And whenever I have a radius that is 1 to the point of tendency, then tangent AC will be perpendicular to the radius MP. If AC is perpendicular to MP, it means that this angle equals to 90 degrees and this angle equals to 90 degrees. In the next step, we will draw perpendicular on the radius MP at point P. Again, we draw perpendicular on the radius MP at point P. So actually, this angle equals to 90 degrees according to our construction. And we'll extend the perpendicular PT until it intersects with the extended ON. We define the touching point between the two extended sides as T. In this way, we created quadrilateral NMPT. This is for the other NMPT. It's not for the other NMPT. We have 1, 2 right angles. The fourth angle must be equal to 90 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. In the next step, we will focus on the right green triangle OPT and we'll implement the Pythagoras theorem on this right triangle OPT. But before that, in quadrilateral MNPT, we have 4 right angles, and any quadrilateral that has 4 right angles must be at least a rectangle if not a square. So we write quadrilateral MNPT as a rectangle, and we know that in rectangle the opposite sides are equal to each other. That is to say, MP equals to NT, but MP is 2, therefore NT must be also equal to 2. Likewise, in rectangle MNPT, MN must be equal to PT, but MN is 7 over 2, therefore PT must be also equal to 7 over 2. We'll define the length of NO as H. So we copy triangle OTP in a new page and we'll implement on this green right triangle OTP the Pythagoras theorem. What is the length of TO or OT? OT equals to ON plus NT. That is to say, OT equals to ON, that is H, plus NT, that is 2. So in total, OT equals to H plus 2. PT equals to 7 over 2. And PO equals to X minus 2. Repeat again. The hypotenuse PO equals to X minus 2. OT equals to H plus 2. And PT equals to 7 over 2. Here by PT is a expression for Pythagoras theorem. According to the Pythagoras theorem, in the right triangle OPT, we get that OP square equals to OT square plus PT square. OP is X minus 2, therefore OP square is X. OP is X minus 2. Therefore OP square is X minus 2 square. It is equal to OT square. OT is H plus 2, therefore OT square is H plus 2 square. Plus PT square. PT is 7 over 2, therefore PT square is 7 over 2 square, that is 49 over 4. We'll open the brackets on both sides of the equation and you get that X minus 2 square equals to X square plus 2 square, that is 4, minus 4X. And it is equals to H plus 2 square. H plus 2 square is H square plus 2 square, that is 4, plus 4H plus 49 over 4. Okay. So I'll copy again this equation in a new page. Here, found out that X square plus 4 times 4X equals to H square plus 4 plus 4H plus 49 over 4. next step, we join points O and C together by a straight line. So what is the definition of the straight line OC? The straight line OC starts from point O, that is the center of the biggest circle, and ends at point C, that is the point of the biggest circle itself. This is exactly the definition of a radius. So OC is the radius of the biggest circle, that is equal to x according to our definition. ON equals to h according to our definition, and we already found out in the beginning of the lecture that NC equals to 13 over 2. So I copy the right angle ONC in a new page, and we implement on this right angle the Pythagoras theorem. OC is the radius of the biggest circle, that is equal to x, or n equals to h according to our definition, and NC equals to 13 over 2. So actually, this is the right angle ONC, and I copied from the original drawing. According to the Pythagoras theorem in the right angle ONC, OC square equals to ON square plus NC square. Okay. This right angle OC square equals to ON square plus NC square. OC is x, therefore OC square is x square is equal to ON square. ON is h, therefore ON square is h square plus NC square. NC is 13 over 2, therefore NC square is 13 over 2 square, that is 169 over 4. So in conclusion, we found out that x squared equals to h squared plus 169 over 4. Now we can substitute x squared in this equation by h squared plus 169 over 4. Do it now and you get that x squared is h squared plus 169 over 4 plus 4 minus 4x, that is equals to h squared plus 4 plus 4h plus 49 over 4. So here we have h squared on both sides of the equation, so h squared will get cancelled. We have also 4 on both sides of the equation, so 4 also will get cancelled, and we left only in this side of the equation we have 169 over 4 minus 4x, that is equals to 4h plus 49 over 4. We subtract 49 over 4 from this equation, and you get that 169 minus 49 over 4 minus 4x equals to 4h. We add 4x to this equation, and you get that 169 minus 49, it is 120, so in total this expression equals to 120 over 4, and is equals to subtract 4x, so it is, here we have 4x is equal to 4x plus 4h. In conclusion, we found out that 120 over 4 equals to 4x plus 4h. 120 over 4 is 30. Here we take 4 as a common factor from those two expressions, so inside the brackets we left with x plus h. Here we divide this equation by 2 and we get that 30 over 2 is 15, is equals to 4 over 2 is 2, times x plus h. We divide this equation by 2 and finally we get that x plus h equals to 15 over 2. Okay, x plus h equals to 15 over 2. What is the length of UN, the line segment UN? UN equals to UO plus ON. Again, UN equals to UO plus ON. So UN equals to UO, that is the radius of the biggest circle, that is equal to x, plus ON, that is h according to our definition. So in total, UN equals to x plus h. Okay, UN equals to x plus h. You can write here that UN equals to x plus h from one side, but from the other side we have already found out that UN equals to 2b. You can write here that UN equals also to 2b. And from those two equations, UN equals to x plus h and UN equals to 2b, we derive that x plus h equals to 2b. But we already found out that x plus h is also equals to 15 over 2, so you can write here that x plus h equals to 15 over 2. And from this equation, 15 over 2 equals to x plus h equals to 2b, we will derive that 15 over 2 equals to 2b. Here we divide this equation by 2, and finally we get that b equals to 15 over 2 over 2 is 15 over 4. So actually, the radius of this circle b is equals to 15 over 4 units. And we already found out that the radius of this circle a is equals to 2, so we can write here that a equals to 2. And finally the ratio b over a equals to b, that is 15 over 4, over a, that is 2. So 15 over 4 over 2 is 15 over 8. In terms of numbers, 15 over 8 equals to 1.875 without units. So b over a equals to either 15 over 8, or in terms of numbers it is equals to 1.875. So the ratio between the radius of this circle, that is b, or the radius of this circle, that is a, it is either equals to 15 over 8, or in terms of numbers it equals to 1.875 without units. In the next step I will summarize the lecture. So in this lecture we found out the ratio between 2 radii, the radius of this circle that is B over the radius of this circle that is A, or the ratio B over A. In the drawing, we have a big circle. Inside this big circle, we have two smaller circles. Again, the radius of this circle is B and the radius of this circle is A. In addition, inside this circle, we have a right triangle ABC that is partially located inside the bigger circle. We know that the length of side AB is 5 units, side BC equals to 12 units in length, and we also know that AN equals to NC. Our mission is to find out the ratio of B over A. So first of all, we implemented the Pythagoras theorem on the right triangle ABC. According to the Pythagoras theorem on the right triangle ABC, AC squared equals to AB squared plus BC squared. I repeat again. In the right triangle ABC, AC squared equals to AB squared plus BC squared. So AC squared equals to AB squared. AB is 5, therefore AB squared is 5 squared, that is 25, plus BC squared. BC is 12, therefore BC squared is 12 squared, that is 144. So in total we found out that AC squared equals to 12 to 25 plus 144. 25 plus 144 is 169, so we found out that AC squared equals to 169. We took out of this equation and finally found out that AC equals to the square root of 169, that is 13. So the hypotenuse AC here equals to 13 units. But because of the fact that at point N, the hypotenuse AC is bisected into two halves, the first half is AN and the second half is NC. That is to say, AC over 2, that is half of the hypotenuse, is equals to 13 over 2. So the first half is AN and the second half is NC. Conclusion found out that AN equals to NC equals to 13 over 2. Each half equals to 13 over 2. Then I presented to you rule number 8 and we implemented rule number 8 in our drawing. According to rule number 8, the radius of a circle that is blocked by a right triangle is equal to R equals to A plus B minus C over 2. So we have the right triangle ABC. The right triangle ABC, this angle equals to 90 degrees. The length of side AB is A, side BC equals to B units in length, and the length of the hypotenuse AC is C. The right triangle ABC blocks this circle. The radius of this circle is R. According to rule number 8, we can know the value of the radius of this circle that is blocked by the right triangle ABC only by knowing the side lengths of the right triangle that blocks the circle. That is to say, the radius of the circle that is blocked by the right triangle ABC will be equal to A plus B minus C over 2A. Again, the radius of this circle that is blocked by the right triangle ABC will be equal to A plus B minus C over 2. So we can implement rule number 8 in our drawing. Because in our drawing we have the right triangle ABC that blocks this circle, and the radius of this circle is A. And according to rule number 8, the radius A will be equal to AB plus BC minus AC over 2. Again, the radius A, according to rule number 8, will be equal to AB plus BC minus AC over 2. Repeat again. According to rule number 8, the radius A will be equal to AB plus BC minus AC over 2. AB is 5, BC is 12, and AC is 13 divided by 2. So 5 plus 12 is 17, 17 minus 13 is 4, and 4 over 2 is 2. So in conclusion, found out that the radius of the circle A is equal to 2 units. The radius of this circle that is blocked by the right triangle ABC equals to 2 units. Okay. In the next step, we define the center of this circle as P, we define the center of this circle as Q, and we define the center of the bigger circle as O. Then we define the point of tendency of tangent AB if this circle is T. Then we join points T and P together by a straight line. Point P is the center of the circle, point T is the point of the circle itself, therefore PT is the radius of this circle, that is equal to A and A equals to 2. The radius TP is drawn, the radius PT is drawn to point T, that is the point of tendency of tangent AB with this circle. Whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius TP. So if AB is perpendicular to TP, it means that this angle equals to 90 degrees and this angle equals to 90 degrees. Likewise, we define the point of tendency of tangent BC with this circle as N. We join points T and N together. We join points P and N together by a straight line. Pn is the radius of the circle that is equal to A, it is equal to 2. The radius Pn is drawn to point N, that is the point of tendency of tangent BC with this circle. Whenever you have a radius that is drawn to the point of tendency, then tangent BC will be perpendicular to the radius NT. That is to say, this angle equals to 90 degrees and this angle equals to 90 degrees. So in quadrilateral PTBN we have 2 free right angles. The sum of free right angles is 90 times 3 is 470 degrees, plus the size of the fourth angle. In total, the sum of those 4 angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, the missing angle must be equal to 90 degrees. So inside quadrilateral TB and P we have 4 right angles. Any quadrilateral that has 4 right angles must be this rectangle and flattest square. So we relate to quadrilateral TB and P is a rectangle. We know that the opposite sides of a rectangle are equal to each other. That is to say, TB equals to Pn, but Tn equals to TB, but Tn is 2. Therefore, TB must be also equal to 2. Likewise, in rectangle TPBN, TP equals to Bn, but TP equals to 2, therefore Bn must be also equal to 2. AB equals to 5 according to what is given as the question. We just right now found out that TB equals to 2, so AB minus TB equals to 80. Again, AB minus TB equals to 80. AB is 5, TB is 2, so 5 minus 2 is 3, so 80 equals to 3. Then we have rule number 2, that the lengths of 2 tangents from a common external point to a circle are equal. We have the common external point, point A. From the common external point, point A, we have 2 tangents to this circle, tangent 18, tangent AM, and according to rule number 2, they are equal to each other. That is to say, 80 equals to AM, but AT is 3, therefore AM must be also equal to 3. Well, we already found out that AN equals to 13 over 2, AM equals to 3. AM minus AM equals to MN. Again, AM minus AM equals to MN. Repeat again. AN minus AM equals to MN. AM is 13 over 2 minus AM, that is 3. So we multiplied minus 3 by 2 and then we divided by 2 in order to have a common factor with 13 over 2. So it is 13 over 2 and minus 3 times 2 is minus 6. So here we have 13 minus 6, 7. So in total this expression equals to 7 over 2. That is to say, MN equals to 7 over 2. This line segment MN is equals to 7 over 2, it's in its length. Okay, then I presented to you rule number 7 and we implemented rule number 7 in our drawing. According to rule number 7, if a line segment that is drawn from the center of a circle bisects a chord, then the line segment is perpendicular to the chord. The center of the circle is here at point O. From the center of the circle, we draw perpendicular, from the center of the circle, that is to say from point O, we draw line segment OM that bisects chord AB. that is to say AM equals to MB. Whenever a line segment that is drawn from the center of the circle by center chord, it must be also perpendicular to the chord. That is to say, OM is perpendicular to AB, this is to say this angle equals to 90 degrees and this angle equals to 90 degrees. You can implement rule number 7 in our drawing. The center of the biggest circle is here at point O. You join points O and then together by a side line ON that is drawn from the center of the biggest circle, that is to say from point O, bisect chord AC. Why? Because AN equals to NC. And therefore, according to rule number 7, you get that ON must be also perpendicular to AC. That is to say, this angle equals to 90 degrees and this angle equals to 90 degrees according to rule number 7. So you can write down that ON is perpendicular to AC according to rule number 7. Then we have point Q is the center of this circle, point N is the point of the circle itself, therefore Qn is the radius of this circle that is equal to V. The radius Qn is drawn to point N, that is the point of tendency of tangent AC with this circle, and whenever you have a radius that is drawn to the point of tendency, then tangent AC will be perpendicular to the radius NQ. If AC is perpendicular to NQ, it means that this angle equals to 90 degrees and this angle equals to 90 degrees. So you can write down that Qn is also perpendicular to NC. Qn is also perpendicular to AC. And from this equation, ON is perpendicular to AC and Qn is perpendicular to AC. So the tangent AC will derive that point O must be located on Qn. Point O, that is the center of the biggest circle, must be located on the radius Qn. That is to say, QON is one straight line. QON is one straight line. QON is one straight line. At this point, this circle touches the biggest circle. We define the point of tendency between the two circles as U. And then we do tangent VW. That is tangent to both circles, to the biggest circle and this circle. Again, VW is tangent at point U to both circles, to the biggest circle and to this circle. So here we have point Q is the center of this circle. Point Q is the point of the circle itself, therefore Q is the radius of this circle, that is equal to B. The radius Q is drawn to point U, that is the point of tendency of tangent VW with this circle, and whenever you have a radius that is drawn to the point of tendency, then tangent VW will be perpendicular to the radius UQ. If VW is perpendicular to UQ, it means that this angle equals to 90 degrees, and this angle equals to 90 degrees. So you can write down that the radius QU is perpendicular to tangent VW. Here, the radius QU is perpendicular to tangent VW. Likewise, point O is the center of the biggest circle. Point U is the point of the biggest circle itself. This is exactly the definition of a radius. That is to say, OU is the radius of the biggest circle that is equal to x according to our definition. The radius OU is drawn to point U, that is the point of tendency of tangent VW with the biggest circle. And whenever you have a radius that is drawn to the point of tendency, then tangent VW will be perpendicular to the radius UO. That is to say, this angle equals to 90 degrees, this angle equals to 90 degrees. So we found out that OU, the radius OU is also perpendicular to the radius, to the tangent VW. So we can write here that the radius OU is also perpendicular to VW. And from those two equations, QU is perpendicular to VW and OU is perpendicular to VW, we will derive that QOU, line segment QOU, is one straight line. This line segment OQU is one straight line. So we found out last slide now that OQU is one straight line. We have already found out that QON is also one straight line. And from those two statements, we derive that NQU is one straight line. NQU, I submit NQU is one straight line. So if NQU is one straight line, then NU also is a straight line. NU is a straight line, but NU is a straight line that touches the circle at points N and U. Therefore, NU is a chord that passes through point Q, that is the center of the circle. Any chord that passes through the center of the circle must be the diameter of the circle. Therefore, NU is the diameter of the circle. So here, NU, UN is the same, is the diameter of the circle. Again, any chord that passes through the center of the circle must be the diameter of the circle. Therefore, NU that passes through point Q must be the diameter of the circle. Okay, NU is the diameter of the circle. And because of the fact that the radius of this circle is B, the diameter must be twice as long as the radius. That is to say, UN or NU, it is the same, UN equals to 2B. UN equals to 2B. Then I presented to you this line segment UN equals to 2B. Then I presented to you rule number 9, and we implemented rule number 9 in our drawing. According to rule number 9, if two circles touch each other internally, then the straight line that connects their centers together must pass through their touching point. The center of the big circle is here at point O, the center of the small circle is here at point M. The straight line that connects their centers together is OM. According to this rule number 9, the straight line OM must pass through point P. If OM must pass through point P, it means that OMP is one straight line, okay? OMP is one straight line. So actually we can implement rule number 9 in our drawing. Why? Because in our drawing, first of all, we join points O and P together by straight line. Point O is the center of the bigger circle, point P is the center of the smaller circle. So OP is the straight line that connects their centers together, and the smaller circle touches the bigger circle here at point S. And according to rule number 9, the straight line OP that connects their centers together must pass through point S. That is to say, OPS is one straight line. According to rule number 9, OPS is one straight line. This is according to rule number 9. So if OPS is one straight line, you know that OPS is one straight line, it means that OS minus PS equals to OP. Again, OS minus PS equals to OP. OS minus PS equals to PO or OP. Okay. Again, if SPO is one straight line, SO is also a straight line. SO is a straight line. What is the definition of the straight line SO? The straight line SO starts from point O, that is the center of the biggest circle, and that's at point S, that is the point on the biggest circle itself. This is exactly the definition of a radius. So OS is the radius of the biggest circle, that is equal to X. So you can substitute OS by X. SP, what is the definition of SP? Point P is the center of the smaller circle, point S is the point of the smaller circle itself, therefore PS is the radius of the smaller circle, that is equal to 2. So you can substitute SP by 2, so in conclusion found out that PO equals to X minus 2. Here, this segment PO or OP equals to X minus 2 units in its length. Then we extended the perpendicular ON by straight line. ON is a perpendicular, it is absolutely a straight line. When we extended the straight line ON by straight line, the result is OT, therefore OT must be also a straight line. If we focus on this side of the straight line OT, at point N, here the sum of the angles must be equal to 180 degrees, according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So reaching this, we have this side of OT at point N, we have this angle that is equal to 90 degrees plus the missing angle, in total they must be equal to 180 degrees according to the rule that I mentioned. Therefore, the missing angle must be equal to 90 degrees. We know that tangent AC is tangent to this circle at point M. Join points P and M together by side line. Point P is the center of the circle, point M is the point of the circle itself, therefore PM is the radius of this circle is equal to 2. The radius PM is drawn to point M, that is the point of tendency of tangent AC with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AC will be perpendicular to the radius MP. If AC is perpendicular to MP, it means that this angle equals to 90 degrees and this angle equals to 90 degrees. In the next step, we draw perpendicular on the radius MP at point P. Again, we draw perpendicular on the radius MP at point P. So this angle equals to 90 degrees according to our construction. Then we extended the perpendicular until it touches the extended ON, and we define the touching point as T. In this way, we created quadrilateral MNPT. Inside quadrilateral MNPT, we have 1, 2, 3 right angles. Therefore, the fourth angle must be equal to 90 degrees. So inside quadrilateral MNPT, we have 4 right angles, and any quadrilateral that has 4 right angles must be at least a rectangle and flat square. So we relate to quadrilateral MNPT as a rectangle. We know that the opposite sides of a rectangle are equal to each other. That is to say, MP equals to NT. But MP is 2, therefore T must be also equal to 2. Likewise, in rectangle MNPT, MN must be equal to PT, but MN is 7 over 2, therefore PT must be also equal to 7 over 2. We define the length of the line segment ON as H. Then I copy the right triangle OTP in a new page, and we implemented on this right triangle the Pythagoras theorem. The length of OT is ON plus NT. That is to say, OT equals to ON, that is H, plus NT, that is 2. So in total, OT equals to H plus 2. So here, this is the right triangle OPT that I copied from the original drawing. OT equals to H plus 2. PT equals to 7 over 2. And the hypotenuse PO equals to X minus 2. PO equals to X minus 2. So we created here the Pythagoras theorem. According to the Pythagoras theorem, in the right triangle OPT, OP square equals to OT square plus PT square. Okay, so OP is X minus 2, therefore OP square is X minus 2 square, and it is equal to OT square. OT is H plus 2, therefore OT square is H plus 2 square, plus PT square. PT is 7 over 2, therefore PT square is 7 over 2 square, that is 49 over 4. So in conclusion, we found out that X minus 2 square equals to H plus 2 square plus 49 over 4. We opened the brackets on both sides of the equation and found out that X minus 2 square equals to X square plus 2 square, that is 4, minus 4x, and it is equals to H plus 2 square, it is equals to H square plus 2 square, that is 4, plus 4h, plus 49 over 4. So I copied this equation here in the new page. This is the equation that we just right now solved. In the next step, join points O and C together by a straight line. Point O is the center of the biggest circle, point C is the point of the biggest circle itself. Therefore, OC is the radius of the biggest circle, that is equal to X. ON equals to H according to our definition, and we found out in the beginning of the lecture that NC equals to 13 over 2. So I copied the right triangle ONC here, and we implemented in this right triangle ONC the Pythagoras theorem. Again, ON equals to H, NC equals to 13 over 2, and the hypotenuse OC equals to X. According to the Pythagoras theorem, in this right triangle ONC, OC square equals to ON square plus NC square. Again, OC square equals to ON square plus NC square. OC is X, therefore OC square is X square, and it equals to ON square. ON is H, therefore ON square is H square, plus NC square. NC is 13 over 2, therefore NC square is 13 over 2 square, that is 169 over 4. So in conclusion, we found out that X square in total equals to H squared plus 169 over 4. So we can substitute x squared in this equation by x squared plus 169 over 4. We did it and we got that x squared is x squared plus 169 over 4 plus 4 minus 4x, that is equals to x squared plus 4 plus 4x plus 49 over 4. Here we have a square on both sides of the equation, so x squared will get cancelled. We have 4 on both sides of the equation, so 4 also will get cancelled. We left only this side of the equation with 169 over 4 minus 4x, that is equals to 4h plus 49 over 4. We subtracted 49 over 4 from this equation and found out that 169 minus 49 over 4 minus 4x equals to 4h. We added 4x, actually subtracted, we added 4x to this equation and found out that 169 minus 40 is 120, so in total this expression equals to 120 over 4. 120 over 4 equals to 4h plus 4x. So we added 4x to this equation. Repeat again, I found out that 120 over 4 equals to 4x plus 4h. 120 over 4 is 30. Here we took 4 as a common factor for those two expressions, so inside the brackets we have x plus h. In conclusion, found out that 30 equals to 4 times x plus h. We divided this equation by 2 and found out that 13 over 2 is 15 and 4 over 2 is 2. So total this expression of 30 divided by 2 equals to 15 equals to 2 times x plus h. We divided this equation by 2 and found out that x plus h equals to 15 over 2. Okay, x plus h equals to 15 over 2. What is the length of line segment UN? The length of this line segment UN is equals to UO plus ON. Again, UN equals to UO plus ON. That is to say, UN equals to UO, that is x, it is the radius of the biggest circle, plus ON, that is h. So in total, UN equals to x plus h. So can I tell that UN equals to x plus h? UN equals to x plus h, and we already found out that UN is also equals to 2b. So here we can write down that UN is also equals to 2b, and from these two equations, UN equals to x plus h and UN equals to 2b, we will derive that x plus h equals to 2b. But we already found out that x plus h is also equals to 15 over 2, so we can write down that here that x plus h is equals to 15 over 2. And from this equation, 15 over 2 equals to x plus h equals to 2b, we will derive that 15 over 2 equals to 2b. Here 15 over 2 equals to 2b. We divided this equation by 2 and found out that b equals to 15 over 2 over 2, that is 15 over 4. So finally found out that the radius of this circle b is equals to 15 over 4 units, and we already found out that the radius of this circle a equals to 2. So b equals to 15 over 4 and a equals to 2. Then we divided b by a. Our mission is to find out the ratio of b over a. So b over a equals to b, that is 15 over 4 over a, that is 2. So in conclusion, found out that b over a is 15 over 4 over 2. 15 over 4 over 2, it is 15 over 8. So we found out that the ratio of b over a equals to either 15 over 8 or to 1.875 units. So I repeat again, the ratio between the two are the I, that is to say the ratio between the radius of this circle, that is b, to the radius of this circle, that is a, or b over a equals to either 15 over 8, or in terms of numbers it is equals to 1.875 without units. Okay, thank you very much.